Welcome, Houdini fans. Welcome to another episode of Houdini Secrets Live. My name is Chris Rhoda, and I will be your Houdini instructor for the afternoon. Now, last week we looked at Mixamo, and then we used the agent SOP in order to go and take a look at that, bring it into Houdini, play around with it. Well, actually, you really can't play around with it much. The agent SOP is part of a much larger crowd system, and it's a little bit of a black box. But anyway, we were able to bring it into Houdini, set it up with export all of the contents using VAT, which is the Vertex Animation Textures, which is a product by Side Effects Labs, and we are able to pull that into UE4. Now this week, what we're going to do is we're going to do the same thing, but we are going to masticate. We are going to digest the Mixamo content and in order to make it our own, get rid of the black boxy stuff, get rid of all the juicy stuff, and so that not only do we avoid having to associate the rig from the animation, but the animation, multiple animations can be used at various times in order to drive the model. So that is the extraction we're going to do, and then we're going to bring that into UE4 again and get things going. So fire up your Houdini session, bring up your last project if you have it. Oh, I forgot. I tried to put the last project up on GitHub, but since I am not paying for GitHub, then I'm afraid we hit a maximum limit on the file size, so it didn't like it. So maybe the stuff that we put up this week will be a little bit smaller. Who knows? But if you want me to go and get a much bigger server for GitHub, then go ahead and subscribe. Tell all your friends, tell all your friends' mothers and their sisters and their brothers and their fathers and their uncles, and have them subscribe so that we can start generating some money and actually start paying for some real resources here. Anyway, a little bit of brevity here. All right, I'm going to go and shift things over to Houdini. So let's see, Houdini Secrets lecture. Okay, woo, look at that. Okay, that is craziness. Okay, so hopefully that brings it up, and hopefully we have Houdini. I'm going to wait for the feedback to come through on my YouTube signal. And here it comes. Hey, we are good to go. And with that said, it is time to get naked. Getting naked with Houdini. Now, a lot of people don't necessarily like doing character animation in Houdini, but I kind of like it. I like working with CHOPS. In fact, I love working with CHOPS. CHOPS, by hands down, is my favorite feature of Houdini, and I just can't get enough of it. And so I do whatever I can in order to get things going as much as I can with CHOPS and Houdini. So I am going to go in and pull up a new tab here. So just as a reminder, where this all came from, and in case this is brand new for you, you can at least catch up and kind of piece things together. And if you have any problems, contact me and I'll help you out. But I'm going to go ahead and pull up my Google here and draw into Mixamo. All right, log in. Okay. All right. Okay, so we are in Mixamo, gang. Now, as a reminder of what we did was we went over to the characters tab here, and then we ordered up a character, and I chose the dummy character. Now, you can choose any character that you want. Look, the racer character isn't too far away. I wanted a good generic character that I could change the texture map and maybe get some texture atlasing going here for a future problem. But we have dummy here, and so that's what I chose was dummy. It says, yes, use this character. And then we downloaded this guy, and then we made sure that he was in the T-pose. All right, once we did that, then I made sure, when I went over to the animation, And what I did was I did a zombie walk or a zombie run. Let me see if this this actually brings up what we downloaded. Ah, here it is, zombie run. Okay, that's what I pulled down, zombie run. Now, when I downloaded zombie run, I did it with FBX and I did it without the skin. I don't want the skin on this because I just want the pure animation data. And we changed this to 60 frames per second. And with the keyframe reduction, we wanted none. We went ahead and downloaded that. Okay, so now we have our character and we have our animation data. Now, if you remember last week, we downloaded the character with the animation with the skin. And so that had the skeleton and the rig embedded in with the animation together. They were just one piece. And that was okay for one thing, but this is good for some other things that you're going to find out. All right. With that said, I'm going to go into a brand new Houdini scene. Oh yeah, I want to make sure that we're already set the project here. And so I'm going to, you know, different strokes for different folks. What I like to try to do is import just from the FBX raw right into the scene. And you're going to see what we do here. So we're going to go import, and then I'm going to go Filmbox FBX. Okay, for those of you guys that don't know, once a long time ago, Motion Builder was known as a 3D animation package called Filmbox. There you go. And Filmbox is the folks that invented FBX as a way of transporting animations back and forth. Well, Autodesk bought up Filmbox, changed it over to Motion Builder, and took over FBX. And now FBX is probably floating their boat. And right now, I can tell you they're probably pooping their boots right now in anticipation of USD. But we are going to import a Filmbox FBX, and I'm going to import. I downloaded this to my character, and so this is character or ch32 non-pbr.fbx. I click accept. There it goes. Come on. Oh, I didn't choose it. There you go. Click import as a new. I'm just going to import this as a new scene, and I'll say discard and new. All right, then we have our character. And then I'm going to rename this character to Dummy Kinda SRC. All right. Now, we don't see our dummy character. Oh, there he is, right there. And it's a little difficult to tell his size because whenever you're using Mixamo and Houdini characters and UE4, it's good to be aware of your size because Houdini characters are 100 times larger than in UE4. That's because in Houdini, their units are in meters, and in UE4, the units are in centimeters. And so when that means you translate something from Houdini to UE4, it translates into 100 times larger. So there you go. And so let me go ahead and put on the grid here so we know just how big it is that we're working with here. And all right, so here's our character. He's 125, so it's a pretty big character. All right, that's good. So what we're going to do is we're actually going to use some good old-fashioned Houdini in order to break down this character and kind of make it our own, because right now it's kind of a black box. All right. Okay, there's our stuff. And here there's two nodes right here. And I'm going to pull this right up to the top here. Okay, there is the hips node for our skeleton. And this is our material node, this is our geometry node, and this is our materials. And okay. And I'm going to drop into the, I'm going to just drop into here, and All right. Now notice here that we have this file node, this is CH32, and this bone capture, CH32 capture. And so this is captured, and we have this override thing. But notice that these are orange. What does this mean? It means that these are frozen. That means the data that it represents is frozen, and it's embedded inside of the Houdini scene itself. So it's tucked inside of the Houdini. You can't see it, but it is there. So what we're going to do is that we are going to put down a ROP export node, or I'm going to do a I'm going to go ROP. What do we want here? ROP geometry output. Yeah, that's what we want. I'm going to put a ROP geometry output, and I'm going to put dummy source out. All right. And then I'm going to click onto that, and I'll look at the parameters, and I want to valid frame range. I want to do the current frame. That's all we want. Red Earth take, SOP path, and we have it hooked from up there, so we don't worry about the output file. And I want to change this, and it's going to be $job / geo, and I'm going to call this demo dummy .bgeo.sc. Okay, so let's go ahead and save to disk. All right. Now, basically, I took all the data that this represented to, whatever format it is, I don't know what, and then I exported it out to a file in my geometry called demo dummy bgeo.sc. And so I just kind of stored that in a safe place. Now, what I want to do is bring this back in. So I'm going to go and drop a file node in here. Hello. All right, we got a file node. And then I'm going to call this dummy import. And look at that. We're upside down. So, come on, get rid of that. All right, so where we go, I got my job. You got geo. And then here's demo dummy.bgeo. Okay, accept. And then we're going to click that into place. And look at that. You see his legs shifts very slightly. And that is because it is the raw geometry. And this raw geometry has not been attached yet to the skeleton. So what we're going to do is attach this guy to the skeleton. But instead of just slapping it in there, I'm going to make things a little bit more elegant. And I'm going to use a switch. So if I ever wanted to use this as a digital asset, I'll be able to do this. And so I'm going to move this over here to 1. All right, so I've got that switch, and then go into my override and my deform, and you see he straightened right up there. Okay, so that's good. So we're done with that character there. Okay, which is good. All right. Now what we're going to do is here we have is the materials here. And inside of that, we have CH body. And here we have this material, a albedo multiplier, bump, and a texture. Okay, so it's got a texture. It's got bump and normals. And it's got one texture in here called CH32, one diffuse. And there's also a normal texture on here. I'm not going to deal with the normal texture right now. I'm just going to deal with just the diffuse on this. Okay. And so here's what we're going to do. We're going to extract that information. You're going to say, well, how are you going to extract this? This is like stuck inside of this node here. Aha. Well, there are ways. All right. I'm going to drop down a COP network. You say COP network? You mean what are you going to do with the police? No, 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 no. Okay. We're going to call this COP network extract dummy diffuse. Okay, a COP network, probably most of you have never used COPS before in your life. It's actually a decent package. It's not great, it's not wonderful, but it is decent and it gets the job done. And we're going to demonstrate right here. And in order to demonstrate this, I'm going to change my pane type. I'm going to add a new pane and I'm going to put a viewer. I'm going to create a context viewer because we're going to see, okay, what do we see? The dummy diffuse. Let's see. There we go. I'm going to drop into extract dummy diffuse. All right. And now what I'm going to do is lay down a file chop. You say, file? What are you going to bring in here? We don't have any file. Aha. Okay, here is the default butterfly. All right. Now, if we go back and look at the material and go into the node here, we've got here's the path .fbm/32 _ diffuse.png. Okay, fine. That's all great and fine. What does that mean? Okay, what that means is we know exactly where all this information is. We may not be able to see it, but it's, so as we put file here, I'm going to put Control V in there. That's .fbm ch32/1001 diffuse. I'm going to hit enter. And there it is. There is our texture map. And it is ours now for our use. Okay, how do we know that? Well, all right. This is a little bit of history, folks. Houdini is an old Unix program. You say Unix, you mean Linux? Yes, we mean Linux. And once a million years ago, ooh, this is important. I just noticed here, if your thing has switched over to the Mixamo COM as far as the takes are concerned, change that sucker back over to main. And we want to change that over. So I'm going to go in and re-pull in my object. Okay, so that's pulling in. Okay, there we go. There we have it. And so, yeah, I don't want to deal with the takes. I just want to use the main take automatically, and that's what happens when you start playing with Mixamo characters. You got to start worrying about takes, and I don't want to deal with that right now. But anyway, long story short, old Unix program. So Houdini is ultimately really just a very fancy database. And the database is laid out just like a Unix file network. And so therefore, they have the root. And the root is slash, or there's just nothing there. Okay, inside of the root, you'll find a folder called .fbm. You say, really? I say, yes. This is where I could go and show you at some other time here, but there is a folder there called .fbm. And inside of that, there is a folder that holds our PNG file, which is here. Okay, but we're still not done yet. Just because we've extracted it doesn't mean we're quite ready. So what I want to do is I want to write this out into another PNG file so that we have this. So I'm going to do a ROP file output, and that's a ROP comp, and it says, and I just want the current frame range. So I just want the current frame, and the output picture, I want to use $job text, and I'm going to call it dummy diffuse. Okay, I'm going to call it demo dummy diffuse .png. All right, I'm going to leave everything so the demo dummy.png, and I'm going to click that, and then I'm going to hit render, and it's going to plug, it's going to chug, it's going to think about it and hem and haw for a moment. There it goes. It's writing out that. So it's taking whatever this content was embedded inside of our Houdini scene, and now we're extracting it and putting it inside of an external PNG file. So this is cool. Like now if we wanted to go and take this dummy and then we wanted to paint the TechArt EDU logo on this dummy's chest. We can now grab it and take this into our favorite painting package, paint whatever we want. We could paint tattoos on this guy's face, and now we will now have a brand new texture that we can use, and it's based on the original thing. So ha 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 ha. You thought this information was lost, but no, it is found. I am going to save this Houdini file before I do anything, and then I'm going to call this. I'll call it demo dummy source. Demo dummy SRC. All right, so there we have it. And we don't see anything right now. That's because what we have here is this. And so what we have to do is go ahead, and it's looking for the default, and there's nothing in here, and it's like we're looking at the wrong thing. There's like we click this on, and it's going to disappear. Okay, la da da da. All right, so I'm going to change this back over to job, geo, demo dummy. Oops. Demo dummy.bgeo. Click accept. Okay, now we see our rig on here, but we don't see the texture. Okay, why is that? Well, it's because we've extracted the texture from it, and we are no longer looking at the raw input anymore. If we were to look at the raw input now, if we were to click this on here, we might actually see the texture, or if we go back to the mixamo.com, there's all the information. But since we were working from main, and we want this, then I'm going to make sure. Okay, there it's come back. Okay, we are now looking at that. Now we have everything ready to rock and roll, and we are with it. And so we are, let me go ahead and save this again, because I know we're doing some monkeying around. All right. So I'm going to save this. And then I'm going to save it again, save as. And so I'm going to go demo dummy, and then I'm going to go HDA source. I'm just going to, I'm just calling it demo dummy HDA, because we're going to build the demo dummy digital asset from here. Okay, so now we basically made a duplicate of original source. So we go up here, and we're already on here. We're doing good. We're doing fine. All right. So I'm going to come back up here, and then I'm going to rechange my network name to demo dummy, just to demo dummy. I'm going to leave that as. I'm going to right click on this, and I'm going to turn this into the whole thing as a digital asset. So create digital asset, and I'm going to change my operator name to just be demo dummy. And there is the operator name, demo dummy. And I'm going to make sure that this is in $job / OTLs demo dummy.hda. Click accept. Dum 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 dum. Okay, yes, okay, we said I wanted to resolve these modes. Okay, there's stuff in here that have absolute paths in here, and we are going to eventually get rid of those, but for now we're just setting things up. I'm going to click OK, and then I'm going to click accept here just to get things started. Node to convert deleted. Okay, I'm not sure what that meant. That is new, but here we go. Here is our type properties. We are going to be spending more time in type properties, I promise you. But for now, I'm just going to accept, click OK, and apply, and just get rid of it. Okay. Now, depending on the geometry that you downloaded, you might actually find yourself a situation where you have more than one object. Now, in my original geometry, I have all this, then there might have been more than one object. Now, this object is just one object for this character. I've done Mixamo characters where there's been 4 or 5 objects. So you need to do this process for every one of those sub-objects. So if you've got all these sub-objects, what do you do in order to pull it all together again? Well, you just kind of set it up the way we exactly set this one up. And then what we're going to do is we're going to create one more geometry here. And then I'm going to call this demo dummy geometry. All right. And I'm going to turn off this guy because I don't want this anymore. Because I want to make sure we do this. So I've created my my dummy DO geometry. I'm going to drop into there. Now, there's a whole bunch of different ways of doing this, and this is going to be, once again, the old school Houdini approach, and I'm going to use a merge object for this. So I'm going to go merge. I'll go object merge. Now, this is a little bit of an old-fashioned dealio, but remember how I said that your object might have been composed of multiple objects? Well, we're going to pull in multiple objects right into here. You can have as many objects as you want. Here we have is one object here. We can have 2, 3, and these, as you can see, these are slots for all those available objects. But for our demo dummy, we just have this one object. So I am going to first make a reference in to my object. I forgot. The one thing I want to do, and then I want to put a output node. And then I'm going to call this CH32 source out. Source out. Okay. And just to be clever, make sure that it's green in color so that I know it's there. Okay. And for be consistent, so here's my official input now. And I'm going to color this guy yellow to make sure that we understand we've got our input and our output. All right, I'm going to go back into here. And now what I'm going to do is I'm going to type in the relative path for this. Now, it's very important because we intend to do this inside of a digital asset. And whenever you're working in a digital asset, you got to work with relative pathing. So get into the habit of relative pathing. So we got dot dot. That means this, okay, up one directory, over, up one more directory, over, and then, okay, there's our folder, CH32. There we go. And then we want CH32 source out. Okay, there it is. All right. Now, this gets kind of funky, and then you got to know a little bit about object space and world space and so forth. But currently, this object is right now inside of its own object space. And if you bring in more than one object, each object is going to be in its own object space. So what we have to do is transform and put all of our objects into one specific space. Now, if you hit the transform knob, you can choose into this object. And so what this does is it coalesces all of the geometries and merges them into one piece of geometry, which goes into this object, which is fine. But I like to push things a little bit into specified object, and then I use a dot. Okay, dot is once again old-fashioned Unix to mean this location. So I want to merge all of these geometries into this object's location. And you'll notice here that if we wanted to invert the transformation or create point groups or create primitive groups or all of these all became available to us that weren't here before if we had none, or if we had into this object, these weren't necessarily available. So necessarily I'm going to use the into specified object, and I'm going to put the dot, meaning that it essentially means the same thing as into this object, but we have more options. More options are available to us. Once again, old school Houdini stuff. All right, now we notice that this guy is in the nude also because he doesn't have a material. So what we have to do is we have to create a material for this guy. So let's go up here, and I'm going to create a new material network. And then I'm going to call it demo dummy. Demo dummy mat network. That's a long name, but hopefully it describes exactly what it does. I'm going to double click and go into my material network, and then I'm going to lay down a, whoops. I'm going to lay down a principled shader. So I'm going to hit tab and I type in principled, and we want a principled shader. Okay, why does it call principled shader? I don't know why Side Effects chose the name Principled Shader. It has something to do with the original PBR paper that Disney put out a handful of years ago when it introduced the world to its version of physically based rendering, and it created a general all-purpose shader called the Principled Shader. Houdini went ahead and it copied that, and it chose the same name as Principled Shader. So it keeps the same spirit alive. Now for this, all we're going to do is change the base color over to white and make sure it looks sexy. And the bump normals or the textures, we are going to click on the base color. We're going to use the texture, and for the I'm going to expand this. There it is. And I'm going to look for my texture that I wrote out. So it should be in text. And there is my demo dummy diffuse.png. Excuse all the demo diffuse and dummy diffuse. This is all created for the prep. Now notice, however, this is kind of interesting. Notice that the JPEG is brighter than the PNG. Does anybody out there know why? There is a specific reason for it. Okay, we're going to choose demo dummy diffuse.png. Click accept. Okay, the reason why it's darker is because it is in, it's not in linear color space. It is in, oh, I'm having a brain fart, but needless to say, it is not in, it's in sRGB space. And we don't want it in sRGB, so we want it in linear color space. And linear colors tend to look a little bit darker when you see them like in a texture like that. Now, if you don't, okay, I think I'm going to have a lecture just for Tech Art Talk Live, just on what linear color is, because linear color is such an important thing when it comes to rendering and lighting, and hardly anyone knows what it is. So I think I'm going to have a lecture on just linear color one of these, okay, possibly in a couple weeks. Note to self. All right, for the source color space, I'm going to use automatic. It goes linear. Okay, then we want that, so it's good. And for the principled shader, I am just going to call this shader, I'll call it demo dummy M. Demo dummy M. Keep it in the UE4 naming convention space. Demo dummy M. All right, so we've got our demo dummy, and so we're going to go back into a demo dummy geometry. And then what I'm going to do is I'm going to drop out there, and I'm going to grab a material node. I'm going to drop that in there. And now for the material, I am going to use my relative pathing again. Go dot dot slash, dot dot slash. All right, and now here we are. We're going to find our demo dummy material network. There it is. And then we have demo dummy M. Okay, that's what we want. We click on the display, and we have our texture back. Okay, we are good to go. Now, like I said, I didn't put the normal texture on here. I didn't want to deal with that because that's just we're doubling up on the thing. But if you want to, you could use it as an exercise in order to see if you would be able to do the normal in order to get the normal bumps in there as well. All right, and now we've got that, and we've got the material, the relative path in there. So I'm going to just create another output node. And I'm going to put output, and I'm going to go demo dummy out. Demo dummy out. This is the official demo dummy. I'll put the display flag on here. And just to be thorough, I'm going to color this guy green. And then I'm going to color this guy yeller. All right. We are good to go. And here, because this demo dummy geometry is the cat's pajama, this is the one that we want, I am going to C, and I'm going to change the color on this over to be green because I know this is the one I want. And then I'm going to change its shape. So I'm going to hit the Z key, and then I'm going to choose my node, and then I'm going to put this spiky star here. So this is like, this is the thing. This is where I want to export from. This is the star of the show, this guy right here. All right, and then we have our demo dummy material network. All right, we've got everything set up pretty decent now, and we actually don't need all of this stuff anymore because we've got it all written out. So I am going to go ahead and delete these characters. Notice that nothing changes because we're no longer using those. We've fully separated ourselves from all of the old material. Now, there's a couple things that I want to create ahead of time. This is just kind of like my old experience as a rigger. Notice that we start at the hips. Okay, if you're going to be exporting a skeleton to a rig, almost every skeleton goes into a game needs to have a root joint. And the reason for that is because there's a little difference between games and film is that a character can move around and its foundation or its anchor can be at the hips, and it's not going to make any problem. For a game, the game needs to know exactly where the root of a character is at all times. So to make a long story short, games are a little sloppier in the regard that it handles animation, and they're all pretty much dependent on a root node. So what we're going to do is we're going to create a root node. So I'm going to add a null node. I'm going to drop that in here, and I'm going to call Mixamo Origin 8. Mixamo Origin 8 underscore capital ROOT. All right. Now, nothing happened, but what might have happened is that when you connected these two, your character might have shifted. And that's understandable. So in order to prevent that from happening, click on the Mixamo Rig 8 hips, and they say keep position when parenting, and then parent it to the root, and now nothing is guaranteed. It's going to stay in the exact same, and we want that. And I'm going to make sure that the root is not grabbable and it's not displayable. We just leave it as is, and I'm just going to leave that as is. All right, so there's one extra thing I'm going to do with this, and you're going to see why I created this in a little bit. I'm going to create one more null. And I'm just going to call this null anchor. You say, why are you calling it anchor? Be patient with me. So I'm going to go ahead and give this guy a color, yellow. So that means that it is the starting place. This is the source of it all. And to know that it is the starting point or the anchor point for my character, I'm going to change its shape. And I'm going to make sure it is a circle. And I'm going to make sure it's ungrabbable and undisplayable. And I'm going to make sure Mixamo Rig is keep position. And I'm going to connect this here. And, oh, I just saw a surge here. Welcome to Florida. Save. Okay, cool. Now we've saved it. All right, hopefully you've saved it. And so we've got our character set up pretty good for it. Now you might have an extra node in here for all of the pieces of geometry and so forth. And this is fine. And there's other ways that you could have treated it in order to make it look a little cleaner. And I just made it so that it was easy to follow. All right, now now we've gone and finished our cleanup. We have to go and kind of go into a rigging now. And you say, rigging, okay, well, let's go into rigging. In order to go and do rigging on any Houdini skeleton, what I like to do first is create my rig crawler. You're probably going, rig crawler? What the dickens is rig crawler? I will show you. I'm going to go ahead and add a new shelf to my tools here. And I'm going to click New Shelf. But I'm going to see if I actually have my old shelf that I was working on this. What did I call this? Oh, yeah, HSL. Yeah, okay. There's my rig crawler. Okay, so there's my old one. I'm gonna change my name here. I'm gonna call this rig crawl old. So let's go ahead and accept that. So I'm gonna have to change its display name. Old. Okay. Okay, so this is the old. I'm gonna create a brand new script here. Anyway, so new tool. And then I'm gonna call this rig crawl, and then the label is rig crawl. All right, and for the plasma icon, that's cool. I'm gonna leave things as that. Click apply. Okay, there it created our brand new script. I'm gonna go over to the script tab and we should be good to go. Now we are going to be using Python for this, so make sure that your script language is Python for this particular tool. Okay, notice, okay, here let me explain a little bit about this. I'm gonna close this and then we're gonna come back. Okay, we're now looking at the rig. Here we have our anchor point, which goes into the root, which goes into the hips, and it goes into all of this kakamaka on here. Actually, as far as rigs go, this is disgustingly clean. This is clean as silk. But let's take a look at this. So we have our hips, and then our hips is attached to, there's a hips bone, which is okay. But look at this, it's also to another null node, which is the upper left leg, and then the bone is hooked off of that. And that also another child is the left leg, and the left leg bone is hooked up of that. So left up leg and the left leg bone. Okay, here's the thing in Houdini. It's a little bit of a different departure from Maya or any other kind of package that you're used to. Houdini, or for at least as far as the Mixamo package is concerned, it embeds all of the animation right here inside of the null node. You'll see that it's got translation and rotation and other stuff put right into it and so forth. That's put in right in there, and that's all good and fine. But you'll see that the bone itself, this is kind of like two Maya joints put together into it. And you can see right here, this is the whole bone. And so we have this joint, and it's basically this joint. So this constitutes as one bone. Off leg bone. And there's a whole bunch of stuff on there. There's the buff, the capture, the bone length, the render. We don't have time to go into bones right now and all and so forth, but just know that the bones in Houdini are actually somewhat passive. All of the animation actually happens in the nulls. All right, remember that. It's good to know for later. Okay, so notice that first, this whole skeleton is turned on, and we want to turn it off. Okay, I don't want to go through every one of these nodes and click each one of these things and turn it off. And it's like, oh God, do I have to do this all day? It's like, oh, this is going on forever. All right. We don't want to have to do this. We are going to use our rig crawler to do this for us. I say, really? Okay, we haven't written it yet. Yeah, we're going to write it right now. All right. So we are going to take advantage of the power of recursion. So I'm going to hit Edit Tool, and we're going to do script, and you're going to go, recursion, oh, my tech art instructor said never use that. Hey, recursion is like part of all the cosmic powers of the universe. Itty bitty living space. This is one of those situations of where you got all the cosmic powers of the universe, and we're going to do something awesome in just a few lines of code, and you're going to see why. Okay, we're going to create a Python function. So we're going to go def. Okay, that's the word for Python function. You know, we're going to create a function, and we're going to call it rig crawl. Rig crawl. And then for the input for this, we're just going to put node. Okay, so that means we are going to send inside of this function, we're going to send it a node. All right, cool. And now I'm going to hit tab, and then I'm going to hit pound key for a little comment, and say, this is where we do stuff. This is where we do stuff. Okay, what do we do? Okay, well, let's just say, we wanted to print the node name. Let's just say, okay, let's just print the node name. So we go print, and then what are we going to print? The node name. Okay, I like to, out of my rig crawler, I like to try to keep my stuff functions kind of abstract, like to do everything in as a function call. And so this is no different. So I'm going to say just node name. Say node name. What is node name? So node name, and I'm going to put node in here. Okay, guess what? Node name is a function that doesn't exist yet. Well, we're going to go and create it right now, just so we don't forget it. So I'm going to go back up here. I'm going to create a brand new function called def, and I'm going to call this node name. And I'm going to put inside as the parameter for the input, we want node. All right, so node name, all it does is it displays a bone. So all we're going to do, actually, all we're going to do is return the node's name. So I'm going to just say return node dot name, and there you go. That's going to do print node name. Okay, so I've created a function that does nothing but just displays the name of whatever node that we're on. Okay, so this is we're done, at least as far as doing stuff is concerned. Okay, we're going to create a new comment here, and I'm going, this is where we do recursion. All right, so this is where we do a query. If you didn't know what recursion is a computer science principle of where a function is self-defined. That means somewhere in this function it calls itself. And so this is where things get to be a little bit mystical, and your brain's probably going to hurt a little bit. Follow with me. This will begin to make sense. So here it is. We're going to do our recursion. We're going to say kids. We're going to create a new variable here. Kids equals node.outputs. Okay, notice here that we have anchor, and then we have Mixamo root. Okay, output. So if I just type in here foo equals, and I'm going to pull down anchor and drop that in there. Okay, so now we have foo. So we have, okay, foo, what nodes are you attached to? Okay, we say, okay, Python, tell us that. We go, all right, print foo dot, and what we go, outputs. Go outputs. Okay, that's a function call, and so where is it going to do? Hit return, and it returns, all right, null. It said foo.outputs. Object of type null. So there are no roots, there are no outputs here? Oh, that's not fun. Well, let's just see what happens here. I'm going to go foo equals, let's say, Mixamo rig hips. Now, this has got to have something. Now, print foo dot outputs. And let's take a look at what the output of that is. It says, returns a tuple of the nodes connected to this node's outputs. Okay, that's exactly what we want. There they are. Okay, so there are all the nodes. You're going, wow, how do you figure that out? Okay, well, this is longhand in Python. And so what these are essentially pointers to objects in space. You say pointers, well, I thought that was in C++. Yeah, it is, but Python kind of does it its own way. If we wanted to make this look a little cleaner, what we could do is say, all right, we could just say, for out in foo.outputs, All right, so we have that. So we're going to go through every one of these one by one. And I say for out and food out outputs, we're going to say print out dot name. All right, so that means we're just going to output the name of every one of those things. Okay, there it is. There are the names of all the nodes of all the children of Mixamo rig hips. Okay, so that's what we did here. So kids equal nodes that output. So it returns a tuple of all the output stuff. That's cool. So we're going to do basically the same thing. We're going to create a for loop here. Say for kid in kids. Okay, so we're going to do a loop for all this. And then while we're going to do this, here it comes. We're going to rig crawl kid. All right. So what do you think? That's it. That's the whole recursion. This is all we're doing. So somewhere in here, we're going to do something. This is where we do stuff. And say this is where we do the recursion. So we're going to just start doing it for all of our kids. We're just going to descend down the tree, and they're just going to do this. Okay, so we've got that there. So how do we start this? So we've got two functions in here. So I'm just going to call this by rig crawl. And then how do I want to do this? I want to start right here at the anchor. I'm going to drag and drop that right in there. All right, now I'm going to click apply. And then I'm going to hit rig crawl. Get ready for this, folks. Dum, dum, dum. All right, there is a list of every single node that's in the entire character tree. So what our function has done is it's magically recursed and traversed and traveled through every single node in this tree. And then once it found itself at a node, it went ahead and printed out its name. Cool, huh? I like it. All right, this is going to make rigging in Houdini a breeze. You're going to see why in a second. So although we just printed out the name of all of the objects in here, not a problem. Okay, no big deal. Let's go and do some real strong stuff here. So let's go ahead and turn off all the bones. I don't want to see these bones on here. We want to turn them off. Okay, so what we're going to do here is I'm going to comment out this statement here. So print node name. And I'm just going to say, turn off bones. Turn off bone. And I'm going to put in the node name. All right, cool. We're going to turn off the bone. Okay, let's create a function to do that. Def turn off bone. And then I'm going to pull in the node. Now, notice that we're not calling it a bone yet. That's because my rig crawler is going to recurse, and it's going to traverse this entire tree. Some of these, this is not a bone. This is not a bone. The nulls are just fine. So, you know, what do we do? Okay, but there are bones in here. So what we have to do is first test to make sure that if we have here is a null or if it's a bone. So we're going to do a test right here. We're going to go if, and we want to ask node, we say, all right, node, give me your type. All right, now in Houdini, the type is not yet the type of the name. It's the kind of, well, I'll best to show it to you. It's a little bit hard to describe. All right, so we got this Mixamo rig hips bone thing, and I'm gonna call this guy bone. Bone equals, and I'm gonna drag this guy out here and put it here. All right, cool. So we're gonna go, okay, bone, give me your name. So I say print bone.name. All right. It says, okay, it says it's the Mixamo rig. Okay, great. Now I'm gonna say, give me your type. So print bone.type. What kind of type are you? and it says it's a node type for object. So it's a class inside of Houdini. It's not really a bone type in there, so it's a class of type. All right, great. That doesn't help us too much, so we have to extend it a little bit. I would say, okay, print bone.type. All right, you've got a type now, and now I have the type. I say, okay, type, give me your name. And I'm going to ask you type name. I hit enter on there. Bone. Okay, so it's now of type bone. Okay, so now we have a way of figuring out whether something is a bone or if it's a null. So all we're going to do is say if type node.type.name equals, and this is a string, so it's, I'm going to put a single quotes bone, other quotes, if node type name equals bone. So if you are a bone, what do? Well, then what we're going to do is we're going to set your display flag as false. So node dot set display flag. Oops, I just spelled that wrong. Display flag, and then we're going to set that to false. All right. So what we're going to do is, okay, set the display flag to false. So basically it means turn it off. Okay, so now we have a function here that descends the entire rig, and if it finds a bone, it says, okay, bone, I want you to turn off. I'm going to go ahead and click apply. And so now let's execute our rig crawl script, and the bones are gone. Okay, it looks like our our nodes our nulls are still on, so we have little displays on for the nulls. Okay, we can deal with that. So let's go ahead and I'm going to copy turn off bone, and I'm going to say, okay, fine, smarty pants. I'm going to create another function here, and I'm going to say instead of turn off bone, I'm going to say turn off null. Ha 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 ha. So here we say if node type name equals null, same thing. So let's go ahead and add this here. So a rig call turn off bone node. So turn off null, turn off null node. All right, click apply, and there we go. It turns off everything. So now we got a way of turning on and off the bones. We got a way of turning on and off the nulls, and we are good to go. Okay, I'm going to go ahead and save this. Now this is a little bit long-winded. Of course, you could have just grabbed everything and just turned it all off that way. But since we're creating a digital asset, we have to do it the digital asset sort of way. So now we have created a technique of turning the bones on and off procedurally. Hint, hint, hint. You notice that procedural term? Ha ha ha. Not by hand. All right, we're going to put this with a rig crawler away for a little bit here. And now we are going to, as promised, start playing around with chops. All right, we've got our dummy up here. We've got and so I'm going to lay down a chop network. Now you folks probably have not ever played with chops either. Get into the habit. I love chops. In fact, I love chops so much, they created a whole program on it called Touch Designer. And Touch Designer is basically like Houdini chops on steroids. And we can talk all about Touch Designer. In fact, if you want to have classes on Touch Designer, I'll be happy to give classes on Touch Designer. But we are going to be working just with Houdini chops for the time being. And we got our network here. We're going to call this animation. All right, we're going to drop into the node. And oh, look at this. Since we have our context view, things have changed, and it's all changed, and we have a whole brand new network on here. See what happens when you explore around. All right, I'm going to drop down a file, chop, and for the channel file name, I'm going to pull in my zombie run export. Remember, the zombie run has no skin associated with it, so it's just pure animation data. And so I'm going to go jobs, and I'm going to go clips, and zombie run, no skin. All right, great. That's what we want, accept. And I'm going to put the display flag, and whoa, look at this. Get rid of it. Go. Thank you. But this is a frickin' mess. We're looking at all of the channels of all the data at once. How many channels is this? I'm going to come over here and look at the information. And whoa, there are 585 channels on here. And the samples go from 0 to 48. Okay, so that goes for frames 1 to 25. Oh, okay, so that means that we've got 25 frames here. It says, okay, well, that's good. And the samples per second, there are 60 samples per second. Okay, good to know. But here are all of this, and there are like quaternions, and there's columns, and there is a whole bunch of stuff on here. So, lots of stuff. 565 channels. And there it is. There's the channel information for every one of those. All right, but this is like unusable. So where it says graphs here, there's a pull-down menu. Come over here, and I want 6 graphs. Why 6 graphs? Because when you're doing game animation, get into the habit of never, ever, or try to never, ever, if you can, animate the scale. Now, of course, you can animate the scale, and it could be part of your gameplay, but the scale is something that shouldn't be animated because it gets kind of confusing after a while. But unless, you know, sometimes you have growing and shrinking characters. And also for every one of these channels, there's 585 channels here. So if you have rotation and translation, okay, that's 6 channels. But if you add scale in there when you really don't need it, that's 3 extra channels. So you're adding 1,500, almost 1,800 extra channels of information, of data, when it's not necessary. So, that's it. Okay, so we've got that. We want 6 graphs. And so where it says graph per single channel, and there we go. And then here's our scale. So auto scale for the horizontally, and this is vertically. And so it adjusts to stiffness. Now we can just scroll through there, and then we look at each one of our channels and take a look at that. Okay, there it all is. It hips. And now usually you're not going to find any information in the translation, usually. It's going to be mostly in the rotation, and that's by design. However, you do have nodes such as like the hips node. The hips node has a translation for sure. And the hips node, and if you had a root node in here, it would have translations as well. But for the most part, we don't want it. All right, but we have all this animation data here. What do we do with it? Well, we use CHOPS and to send it out to our rig. Is that really? How are we going to do that? So all we have to do is just lay down a null node. Boy, we're using nulls out the wazoo. Okay, we got a null node here. What are we going to do? We're going to color it so it's green. And then we're going to name this. Then we're going to name this guy animation out. And I'm going to turn off the display. I'm going to turn on the display on there. So the display is going from one place to another. All right, now the animation out. And so while we're at it, let's just go ahead and for our file node, let's make this yellow just to be consistent. Okay, CHOPS does something really cool. So we're dealing with, how much are we dealing with? Okay, almost 600 channels of data. And we got it all in one itty-bitty living space right here, sitting right in this node, 600 channels of data. All right, what do we do with it all? Well, we send it all to the rig. And they say, how are we going to get all of this animation data over into our rig? Well, that's what Houdini CHOPS is for, and this is all made for it. So what we're going to do is we're going to display on this. We're going to put on the parameters. Well, actually, we don't even need to put on the parameters. All we have to do is come over here and we don't want to bypass this. We don't want to display it, although it is sexy looking over this. And for the output, and this, okay, so what this does is it says, okay, this is my output node, so we don't have this. But we don't have to necessarily display it. But what's this last one? This one says export. All right, export. So if we click this, okay, big deal, nothing happened. Ah, but take a look over here, the information. Now look over here, we have the channel name, so this is what it is, and then we have override over here, and now it says it's doing something. So all of the nodes that were in the rig are now being overridden by this channel data. And so CHOPS ultimately gives us a way of coming in on any data set or any animation in the world. This animation could come from mocap, this could be keyframe, it doesn't matter. We can take any motion stream in the world and then we can monkey with it and we can put it back into our rig. Ah, I love it. This is like the possibilities are endless, and we're probably going to get more into this even more next week. So let's go back to our scene view and look at what we have. Uh-oh, this isn't good. It's hidden. So I'm going to hit Shift H. Uh-oh. Look at this. The character got small. So, uh-oh, it looks like these folks over at Mixamo did exactly what I told them not to do, and it put a scale in here. Let's double check to make sure if that's true. I'm going to go into my context view, and I'm going to click on this file, and I'm going to take a look at the hips. Now, I don't know where the hips are on this, and there's almost 800 of this, so I just want to look at the hips. So a way of doing that in CHOPS is I'm going to go draw that out, and I'm going to type in a delete node. And then we have this delete node, and I'm just going to say only hips. I say, just show me the hips. I'm going to hit there. And it says with the channel names, okay, here's an expression by delete scope channels. I want to delete non-scoped because I want to delete everything but the hips. And so I'm going to type star hips star. Okay, that's fine. So if I hit the display on this, there it is. And there are our 9 channels here. Notice that we've got translation, rotation, and come on over here. It looks like we've got scale, bump, bump, bump. And where is scale? It's at 0.01. How do I know that? If I click on here, I'm pressing over it, and I can see there's a little number that pops up over here, and it says 0.01, or it's SX equals 0.01. If you look over in the lower right-hand corner of the display window, 0.01. Okay, so Mixamo is thinking for us. I hate when they think for us. It's displaying it, so it's animating the data. All right, since it's in the hip node, it's in the parent, and it is propagating that scale to everything. So in my humble opinion, just leave it for now, and just leave it as is. But now we know that, yes, there is scale on this. And we lost our character. Where is it? Oh, again, there he is. Okay. All right, so let's go ahead and turn back on the grid. And there he is. He's small size, and he's all jacked up. Why is he all jacked up? I don't know. But something ain't right. All right. Now, in order to solve this, I really had to put on my sleuthing hat, and I really had to think about this for a while, and I had to go in and explore. So let's go ahead and turn off the animation. I'm going to turn this off and then go back. And up. And you notice the character got big again. And so there it is. All right. So I'm figuring out, okay, maybe we have no idea where this symptom is coming from. Where is this jacked upness coming from? This could be in the rig. It could be in the animation data. I don't know. So what I did was I started looking at some of the data that was in here. Let's take a look at the hips. So the hips is like, okay, that translates, it goes to the 95, the 2 thing. Okay, so everything is looking good. You know, the rotate, it's got channels for the translation, the rotation, the scale. I don't know why it has channel data in here, but it's got channel data in there. Okay, I'm going to leave it on there. Okay, I'm going to go ahead and start looking around at some of this other data. Let's take a look at the upper left leg. Okay, same thing. This translation looks about right for everything else on there. But look down here. The rotations are at 0. Okay, interesting point. The rotations, okay, looky here, folks. If we were to turn on the bone for our left upper leg, okay, it is not pointing along the x-axis. You say, how do you know that? Well, because I've been a rigger for a long time and I know that bones are oriented along the x-axis. Okay, it's pointed down the y-axis and it's kind of like off at shifted off at an angle. But wait a second, the angle, wait a second, it rotates at 0. Ah, so what this has is a pre-rotation on it in order to make the rotation look like 0. I have no idea why they did this, but they did this. And this is confusing as all dickens. And if you come over here, look over here, pre-rotate, and look over here, there is animation data in here, and these values are whacked out. But the character looks good. So maybe these whacked out numbers work. I don't know. So let's see what happens if I turn back on what I'm going to do is I'm going to turn back on my animation data. And the character is going to get whacked out again. There he is. Okay, now I'm going to go to where the animation is the left up leg. And then I'm going to notice that my translations and my rotations are being overwritten. You know, according to that. How do I know that they're overwritten? It's because they're orange. And orange is the magical color for when something is being overwritten by CHOPS, just so you know. So what I'm going to do is for this pre-rote, I'm going to go ahead, I'm going to right click on here. I'm going to say, all right, delete channels, delete everything that you got. Okay, nothing happened. Okay, that's to be expected, but at least I got rid of any of the channels here. If I right click on this and say revert to defaults, uh-oh. The leg bone kind of returned back to some place of semi-normalcy. Interesting. Now, what if I was to go through and for every bone or every one of these nulls, I was to go ahead and kill its pre-rotation and return all the re-rotation, kill all the data, and put it all to 0. And so therefore, only the animation data was driving it. Interesting. So let's open up our rig crawler and say, okay, we got to turn off bone. All right, I don't want to turn off the bones, and I want to turn off the nulls. What do I want to do? I want to remove all my pre-rotations. So I'm going to say remove pre-rots. And I'm going to send it a node. Okay, so let's write the function now for removing pre-rotations. Okay, I'm going to start this off. Def remove pre-rots. And I'm going to import the node. All right, cool. Now, how do we start off with this? Well, first, what we got to do is identify if it's a bone or a null. Okay, how do we test that out? All right, then what we have to do then is basically do what we did with here. If the node type name equals null, and then we're going to set the display. But how about then if it's a bone, we don't want a bone. We just want it to, okay, only do this for the, we only want this for the nulls because the nulls hold the data. So let's say if node.type name, oops, we don't even want it, just type dot name equals if you are a bone. Okay, if you are a bone, go home. We don't want you. Get out of here. So I'm just going to type return. That means if you are a bone, get rid of you, delete you. Don't want you, don't want them, don't like them. All right, so if it's a bone, then we're going to get rid of you. But if you aren't a bone, well, let's just test just to make sure that everything is working. So we're going to go print. Okay, I'm going to go name equals, and there I'm going to go type equals, open and close curly brackets on name and type. And so we're going to go dot format. And so in this, I'm going to go node dot name, and then node dot type dot name. Okay, so we're going to print out everything that sticks around, and we're going to make sure that it is a null node. So I'm going to click apply here, and then say rig crawl. Okay, look at this. Here's the name, and we see that the types of these guys are all nulls. Okay, so we've done a good job of isolating just our nulls. Okay, we are good to go. I'm going to comment this out because I might want to use that sometime in the future. Because we're getting a little bit dicey here. So what we want to do is check out this channel here. All right, how do we know which channel this name is? This is pre-rotate. So I would say, okay, give me your pre-rotations. Yeah, but what are we looking for? If I put the cursor over the channel, the little thing pops up here and it says parameters RPREX, RPREY, and RPREZ. Okay, so we are looking for the RPRE channel. So therefore, we're going to ask node, we're going to ask it nicely. Okay, node, please give us your prerots. So I would call this prerots equals node.parm tuple. And which parm tuple were we looking for? We were looking for the RPRE. So put that as for single quotes RPRE, close quotes. Okay, no, prerots equals parm tuple that. Okay, here we have a little bit of an issue. And yes, I made this mistake and I don't want to delay it for it. If you look over here to some place like Anchor, this Anchor, it doesn't have an RPRE channel. We come over here to root, it doesn't have one either. Hips, it's got this FBX node path, but it doesn't have an RPRE node channel either. Okay, so is this going to cause things to bomb? I don't know, so let's test it. So I say foo equals, and I'm going to bring in my Mixamo hips rig. Okay, so what happens, say print if foo.parm tuple. Okay, what happens if I put RPRE quotes in there? What happens if I don't, if there isn't any channel in here and I ask for it? Okay, none. Okay, so it just returns the null pointer. All right, well that's cool. So that means that we don't have to do anything. So we have to make sure that if there's nothing happens, it is okay. So that's fine. So let's make sure that we have something. So we say if prerots. All right, that means if it's not null, then go ahead and do this stuff. All right. Now notice that there are 3 channels inside prerots. How do we know this? Well, I counted them. If I click on that, notice that there are pre-rots, and it shows there's RPREX, RPREY, and RPRZ, 3 channels. So therefore, when it comes, it's going to give us on the parm tuple, it's going to give us 3 parameters here. So we're going to create a for loop. For pre in pre-rots. So we're going to go through one by one. And what's the command for this? Well, I looked it up ahead of time. So what we got to do is we got to delete all the keyframes. So pre dot, and the command for deleting all the keyframes is, guess what? You guessed it, delete all keyframes. Delete all keyframes. Yep. Okay. And then what we have to do then is we got to take that channel and we've got to revert it to its defaults value. And what do you think the function name for that is? You guessed it, revert to defaults. pre dot revert to defaults. Okay. Bocce balls. All right, we've got this going. So that's all it's doing? So we're going to go through and we're going to get rid of each one of these channels. We're going to get rid of all its data and then revert to default. Is that it? Well, I don't know. I think so. Let's give it a try. So if we hit apply and hit rig crawl, oh, there it is. Character just fixed itself right there. Okay, cool. That's pretty cool. I love it. So cool. Well, oh, there he goes. He's running around. All right. So cool. Let's go back into our animation channel. It says, okay, how many frames is this? So if I go into I, it says, okay, frames 1 to 25. Okay, cool. So that means I am going to set my range from 1 to 25. Apply, and then close. Okay, we got 25 frames here. And I'm going to make sure that this is turned on for being real time. So we've got our character. Oh, there he is. He looks just like Jim Neighbors going after. Oh, we won't go there. But anyway. Yeah, he looks like a zombie running. Yeah, that's what he does. So I'm going to go ahead and save this. All right. All right, so we've done that. So what do we do now? So let's go ahead and make sure. Oh, I know what I need to do. I need to. Oh, look at this nuttiness. That's not cool. I need to bring up my UE4 editor. So I'm going to load up my project. The reason why I'm doing this now, folks, is because it'll take about 10 minutes to load up my scene, because my machine is like dreadfully slow. So here's my UE4 HSL character chops. HSL, okay, it's running. Okay, I'm going to let this percolate, and it's going to take about 10 minutes to open. But in the meantime, let's lay down our ROP network to export this to UE4. So I'm going to hit Tab, ROP, and then I'm going to call this just VAT, V-A-T. We drop into VAT, and then I'm going to drop down guess what? A VAT node. All right, we got VAT. Come on. All right, we've got our VAT node, and we're going to call it Demo Dummy VAT. Demo Dummy underscore VAT. Okay. Now we've got the pull up the parameters on this. Okay, the start and end, 1 to 25. That's all good. Method, okay, we want it soft because we have a constant topology. Okay, very good. Engine, UE4, initialize for engine. Okay, bocce balls, everything is good. Now the SOP path, now what was our SOP path again? Okay, so we want, everything's going to come out of dummy geometry. And then we've got a demo dummy out. So that means we could do anything we want to this geometry, but we're only going to export from this node right here. So that's what we want here. So once again, because we're inside of a digital asset, we're going to make it all relative. We're going to go .. slash .. slash. All right. We want demo dummy geometry. There we go, and demo dummy out. Okay, cool. Frame range, 24 frames. Speed, okay, just leave that. Okay, we want the normalized data range to be from 0 to 1 space. Yes, leave that on. For the pack normals into position alpha, turn that off. For, okay, this demo dummy, he's still about 8,000 vertices, so I'm going to make sure that this is big enough. So here it is a 2048 texture, and so it's big enough here. All right, cool. We can project export. I'm going to call this Demo Dummy Zombie. Boy, that's a mouthful. Demo Dummy Zombie. All right, and now for the component, I'm going to call it just Demo Dummy Zombie. All right, we're going to make sure we want our geometry, our position. Do we need position 2? No, but we do need normal and we do need color. All right. Now I'm going to go in File, Save, and now let's just go ahead and render this. Okay, it's going to plug, it's going to chug, it's going to think, it's going to hem, haw, himmer, and swirl. Okay, we are done. Very good. Okay, and look at this. Oh, there's some other stuff on there, but this is not the map that we wanted. Please excuse all this stuff. We'll go maps. We got the HSL demo map. Oh, and look at that. There's a picture of our dummy running, but I'm going to get rid of this guy because he's too premature. We don't want him yet. Stop it. Ah, there he is. Demo dummy. Okay, we don't want that. That's like a little pre-introduction of what's here to come. Yeah, and these are all just test guys. Please ignore the other men behind on there. All right, we got the demo dummy map. All right, I'm going to save this current here because we don't want it. So let's go ahead and go to our VAT folder and then pull in our demo dummy stuff. Okay, first what we're going to do is bring in our geometry. Import to game VAT. And here it is, Demo Dummy Zombie. Now see, there's my old dummy zombie project. But Demo Dummy Zombie, we're going to click on there. We want to go into the meshes. Demo Dummy Mesh. Okay, you got that. Okay, go ahead, import all. We don't want to change anything. Boom, boom, boom. All right, you can do it. We love you. Come on. We know you can do it. Yes. We know you're there. At one time, this was a fast machine. I'm telling you. I don't know why it's taking so long. Probably because it knows it's live. Okay, great. It just imported. Oh, there it goes. Oh, there it goes. All right, cool. All right, but look at this. The demo zombie mesh came in. And look at this. This is something different. Boy, it is like super slow now. I wonder what's taxing this. Okay, it's got the texture already created. It already created a thing. Okay, now this is something different that when we were exporting from the agent SOP, it didn't give us. It didn't create a material for us. It didn't create a texture map of our existing texture for it. So this is really cool. So thank you. You know, this is one thing that the agent SOP didn't provide for us. All right, note to self. This is why we might want to deconstruct this for ourselves. But for this, we still want our mesh to come in here. We want to use full precision UVs for that. So click on that. So click save. All right, cool. Oh yeah, we want to do this, yes. And then I know that we're going to have to save this one again. All right, so now let's go ahead and bring in our materials. So import to game VAT, export to game demo zombie. Okay, let's look up our textures. So textures, demo dummy zombie, color, normal, and position. Click all three, click open. All right, here they are. So let's go ahead and do the treatment. Okay, next week, not this week, but next week, I'm going to show you guys how to create a UE4 importer so that whenever we go through and we import all of this, it goes ahead and it sets the high precision UVs. It goes in each one of these textures and it sets the right settings for us. This is a royal pain in the butt doing this time and time again because I love this VAT stuff. I do it all the time, but man, I don't dig setting the parameters on all the inputs on this. All right, so what we're going to do, what kind of parameters? We have a compression setting set to the vector for the filter, put it to nearest, save. Okay, we also have to do this for the normal, compression, vector displacement, filter, nearest, save. And for this, the position, same thing. Compression setting, vector, filter, nearest. All right. Good. All right. So what we're going to do is I'm going to take my material file taken from any of these other ones that we are using. So let's go with the agent Hoki. That's this guy here that we created before. So I'm going to take my agent Hoki and I am going to make a duplicate of him. I'm going to hit Control W to make a duplicate. And I'm going to call him, I'm just going to call this demo dummy zombie. So demo dummy underscore zombie underscore M. So this is a material. All right, let's go ahead and adjust this. All right, so there is our network. And so what we have to do is replace all of these texture objects with our current texture objects. All right, so here they are. We want, we've got the color, we've got the normal, and then we have our, oh, no, we don't want that. We want the position. Cancel. There. All right, drop that up here. Okay, first what we have to do, transform these bad boys into texture objects. Texture object, texture object, texture object. Okay, let's wire our position into the first position. Wire our normal into the normal. And wire our color into the color. Gonna hit save. Bum, 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 bum. Okay. Now we've got our demo dummy zombie M. Demo dummy M material. Is this the one I just created? No, this is not. Where is my demo dummy? Demo dummy zombie M. Okay, here it is. Now what we're gonna have to do is make a texture instance, material instance out of this. So right click that guy, create material instance, and I'm just going to change the name ever so slightly. So demo dummy zombie M to demo dummy zombie MI. All right, I'm gonna double click that, and I'm gonna put that up here. And I'm going to turn on the number of frames, the position min, the position max, the pack normals, and I'm going to turn pack normals as off, and I'm going to gauge the speed. Okay, I'm going to let this compile my shaders. All right, cool. So let's go and grab that information from Houdini. So the number of frames, I already know this is like 24. All right, I'm going to leave that as is. So where's my Houdini? All right, there it is. So I know that the speed is 1.25. So I'm going to know that, but I'm going to copy the min position. So I'm going to go and click this to copy the min position. I'm going to paste that right in there. And then I know the speed is 1.25. And so let's go ahead and grab the max. And the max is occupied by grabbing this. Got it. Got the max. All right, I'm going to pump the max right into there. All right. Chaos ensues. This is good. Click Save. All right, now let's go grab our demo dummy zombie mesh and put him in the game. There he is. All right, now let's put the material instance on him. We're going to put that on him. And okay, look at that. We lost the material, but he's animating and he's doing the right thing. So that is good. So let's go ahead and put the material back on it. So how do we do that? We couldn't do that with what we had last week. Aha. Remember that Houdini and FBX and UE4 gave us a material, and it gave us a texture. That here it is, demo dummy diffuse. Okay, so it gave us a texture map to deal with. Okay, where do we know where to do this? Okay, so let's take a look at, let's go back to the original thing and look to the original material function. And I guess I'll start it off with this agent dummy material function. Boy, what a confusing mess. Okay, what I did was I hinted and I hummed and I pawed and I reverse engineered this network until I found something that would have to do with diffuse color. And so I found, ultimately, here it is. Texture coordinate 3, texture coordinate 4 goes into append mask. So whatever is coming, to make a long story short, it's going to take the color map that comes out from Houdini and pump it into the output color. That's all that it's doing. Okay, but that color is kind of like garbage. It doesn't really mean anything to me. All right, so what I'm going to do is I'm going to just get rid of this. Okay, that's good to know. So I'm going to open up my material, my demo dummy zombie material. Okay, so here it is coming from the material function from the base color. We can just override this by creating another texture param 2D. Param. There it is, texture sample parameter 2D. And I'm going to call this diffuse texture. And then I'm just going to bop that RGB right into my base color. All right, that's fine. So I'm going to click Save to get that going. Now, this is just a placeholder. So what we have to do now is we have to go into the material instance and actually give it a corresponding value. So if we open up the material instance, we notice now that there is a diffuse texture parameter in here, but we did nothing in here. So let's pull open that and let's do a search for demo dummy. Demo dummy. And we want demo dummy diffuse. Okay, it's looking good. So I click Save. Now things are looking kind of sexy. Now if we go back into our map, there it is. Our guy has our diffuse map. All right. Okay, so look at that. We've got our character coming in. He's got colors. He's got texture maps. And he's being animated. All right, way wicked. I think we're actually going to be able to create this crowd simulation of running zombies, possibly. Maybe someday. I'm working on it. I won't get it for you next week, but I will get it for you sometime in the future, hopefully before the end of the year. Okay, this is what I wanted to show you folks today. We are going to extend this next week again because we didn't really play with CHOPS that much. And I really wanted to show you some of the cool things you can do with CHOPS. And so we're going to play a little bit more with CHOPS, and we're going to play a little bit more with some other animations and some other sequences, and we're going to get things going, and we're going to kind of mix things around with this, play around with CHOPS a little bit, and you're going to understand the reason why I love it so much. But that's what I wanted to show you. And so this is where we're going to leave off for today and for this week. So if you liked what you saw here, let's get things running again. See, these guys are so happy that they're flipping. Woohoo! So if you like what you saw today, make sure you subscribe to my YouTube channel and check me out on LinkedIn. That's Chris Rhoda at LinkedIn. And if you don't want to go to Chris Rhoda, go to TechArt.edu. Check that out there. Or if you're a Facebook person, go ahead on over to Facebook. Look me up at Chris Rhoda at Facebook. Or go to the Orlando Houdini Users group on Facebook and check me out there. Oh, and speaking of the Orlando Houdini Users group, a reminder, we have our first Orlando Houdini Users group. It's going to be on Zoom. It's going to be on September 11th. So go ahead and check that out. And if you need any information, go ahead and check out the Orlando Houdini Users Group. Check out the invitation, or else send email to me at chris@techartedu.com and say, hey, dude, I don't have information on when the Orlando OHUG is going to take place. Yes, it's going to take place on the 11th of September next month. It's going to be right around the corner. So thank you very much for joining me today. Thank you very much for participating and putting up with all the nonsense that goes on and the chaos that ensues. I look forward to showing you more CHOPS next week. And until then, have a great week. See you later.